Hello from DIYDSP.com. In the last episode, we were taking a look at restoring a classic electronic music instrument I designed called the Electric Eel, a generator-based digital music instrument. I got as far as this piece inside, which is the voltage regulator. I tested it and I found out it was not working. And when I took a closer look at the board, I realized I'd left myself notes on there from back in 2010. And the note actually says burnt out. I don't know if you can see that penciled in on the circuit board there. So it says burnt out and there's a little arrow to the chip. So let's see if we can replace this chip. So just a little bit about this chip. I looked around in my boxes and shelves and things, and I did find a few replacements. This chip is not terribly hard to get. It's a switching voltage regulator. Its part number is the LM2574. This one happens to be the adjustable kind. So the reason I used a switching regulator is because it's much more efficient than a linear regulator. And in a generator instrument, you need to save every watt that you can. So here's another funny story. I'm going to have to cut this chip off. Usually when you design things, you want to put them in sockets so they can be easily replaced. At the time, I guess I just didn't have any sockets. So this chip is actually soldered right into some holes that were actually laser cut into this board. So I'm going to just take off the mounting screw here. Put that aside. This is the CPU here, and the regulator. They're mounted on these rails. So now I can get to the chip itself, and you can see the wires are just soldered right on there. So much so that I don't think I'm going to actually remove the chip entirely. Okay, I think because that would just lead to disaster. So I don't typically like the dead bug method. The dead bug method is where you fit a chip simply directly on top, because you never know what's wrong with the chip underneath. So I'm going to do kind of a stunt for you here. I've never really done this before. What I'm going to attempt to do live for you is remove the top half of this chip, leave the leads in place, and then solder the new chip in. I think it's technically possible. So already the board is marked. There's a 1 on there. And if this works, I even have a voltage supply and a meter. So we can test it out if I'm able to solder this on successfully or not. So stick around, because this could be good. All right, like I said, the chip is right there. I've got the exact replacement right here. I'm going to attempt to cut these leads off one by one, very carefully, leaving as much of the lead as we can intact. That's why I'm using my good pliers. These are my all-purpose pliers, but these are the very sharp ones that I hardly ever use. Have your extra sharp pliers around. Okay, so the pin cut off very easily. The question, though, is how much of it is going to stick through so that I can solder to. So I'm going to take a different angle like this. I don't know if I can get in there. Yep, I definitely got in and left a whole lot more of the pin. Let's see if you can get a close-up of that there. Sorry for the shaking. There, you can see that first one didn't leave much, unfortunately. But okay, let's keep going. Okay, so that's the entire side removed. Now I'll work on the second side here. I hope you can see that in there. Let's try putting the pliers almost completely flush with the body, just getting looser and looser as time goes on. It has no stability other than these legs. There we go. They're all coming off really well. Okay. There we go. Ready? We're going to remove this chip. Bam! It's gone. Woo! So normally I would label a chip like this that I removed that was suspicious, but this one has all the legs cut off. So something tells me no one's going to use that one again. Okay. Now that was the easy part. Anyone can just cut off a chip like that. What we have to do now is take this brandy new one, hold it in such a place that we don't get any shorts and that we connect all the pins. There's just kind of enough slack in all the holes to do that. You know what? Somehow I think I lost the entirety of pin 1 there. Oh boy. And let's see. So for another nice feature of the circuit board is it actually, take a look, it has all the wiring on there. So all those arrows show you how you're supposed to wire it underneath. You know, when I did this 7 years ago, Osh Park was just starting out. I don't know if they actually even existed then. It wasn't as easy to get small prototype boards like this. So, you know, I had the laser cutter, and that's what I made. So a nice thing about that is that we can now see, let's get a little screwdriver here. I see that pin 1 has got a dashed line going up to that. So that happens to be the voltage input. So that tells me pin 1 is the voltage input there. And see, it looks like this red wire used to connect there, but I knocked it out. And I don't think that pin 3, or technically that's actually pin 5. 5, 6, 7. So pin 7, that seems to just be a ground. It doesn't seem to be shorted to that at all. So let's get the chip in connected to all these other pins. Hopefully that doesn't come loose or any of these. I'm going to have to use just the right temperature. I'm going to go to, I don't know, 750 Fahrenheit. Okay, so now we're going to put it back in place, making sure I get the orientation correct. So this side's pretty easy. Twist it a little bit. Alright, so I'm going to solder this one in on the right side just because it's easy. And that'll give me some anchoring for the whole rest of the system. So, I got a little tiny bit of solder there. Let's get in there and see if we can tack this in place. I'm going to heat up the chip first, the chip side. Just so it has a little advantage. There we go. Little dab will do you. That's tacked. I took a risk and gave it a little bit more. Now for the other 4 sides. These are a little more challenging because I'm not left-handed. I think I could still get in there. Let's just go pick up, wipe off the iron, get a little more solder, just the right amount. Oh, so there's some less than ideal solder on there. I like to make it very ideal. There we go. Okay, so I'm going to heat. Again, I'll do the body just because that's a better heat sink. Dab on there. Flow a little bit and make a mega pin. So hopefully you can see down in there. Alright, 3 more to go. Should probably be using the hands to hold this, but let's do this outer one. There we go, another mega pin. This one doesn't even look technically connected to anything. Another mega pin. Okay, so that's the worst part of it. Let's just inspect the work. Probe it just a little. Actually seems pretty solid. Whew, the worst part's over. But we do have to go and connect that supply pin here. So I don't quite see, it's not a great connection that was made here. So what I'm going to do is I'm going to take that curly bit of wire. First thing is I'm going to distribute some fresh solder on there. See, most of that was just solder. Now I see it's got like a little curl to it. See if we can accentuate the curl. The pliers give a little twist there. This is going to be good if this works. You need a voltage regulator in this instrument because while the player is playing, they are putting different amounts of energy, anywhere from, say, 3 volts when they're barely moving, up to 40 volts. I've definitely had 40 volts, measured on these things. And believe it or not, sometimes enough voltage that burns these things out. I mean, that's, I assume, why we're fixing this one in the first place. Somehow it probably got over-voltaged. A lot of these things got over-voltaged because I didn't really know how high they're going to get. You have a variable system, and then it turns out the sound that they're making takes different amounts of power to produce. So it's not on their grate. It's just kind of tacked in place. Let's get that one just a little more quality. It's pretty bad. Come on. Oh, now I'm melting the plastic. Is that stuck to that wire? It is. Oh boy, all right. Burning the wood. That thing is that's all jacked up. I'm gonna have to recut that. It's just too grungy, too much burnt insulation, frayed wires. Forget about it. Just gonna cause trouble down the line. So I'm gonna get, this is like a really awesome set of pliers, It's just the Klein tools, I don't know, made in USA. It goes from gauge 20 to 30. Very sharp. They have the spring. You can hold it in place like that. I have just found, like, that's the perfect range for the stuff I do, 20 to 32 gauge. So let's get in there. I'm going to start with the smallest. I know this is too small. It's 28. Beautiful. All right, so I cut off a little more slack than before. Let's get in there with the pliers. So your CPU, the amplifier in the system, when the player plays the generator, right, and puts, tell you what, let's reverse the curve on this. Because if it wants to go that way, we can use that tension to hold it in place better. Right? Oh. Shout out to my friend Justin, who taught me to always make things physically stable without the solder, then add the solder. Justin Emerson, shout out, Burn Kit 2600. Notorious, brilliant, devious, twisted circuit bending great friend of mine. So now that that's in place all by itself, it's still trying to bridge with that other bit there. Pardon my French. Don't make me have to go in there and trim. I had to go in and trim. But at least that's solid in place now. Okay, this is now dangerous, as they say. Did I mess anything up on the other side? Excess heat? I don't think so. Alright, so we're about to test this. I don't like, it seems like that's just going to short out in a matter of minutes. I don't like it at all. So I'm going to get, do I have, yes, I have some electrical tape. This is not going to hold for a super long time. But let's just test if the whole thing works. And if it does, then we're gonna rejuvenate the whole entire thing and get it tight enough that it can be taken on the road and played by professionals. If you can do a year-long tour on the road without breaking, I think you're really commercially viable, I would suggest. Of course, it helps to have people who know how to fix these things, which is part of why we make the videos. All right, ready? As I said, I've got a power supply ready to go. Just looking at it one more time. It's like watching your kid have his first day at school. So I'm going to put in the ground here from the supply. put in the V in. Now over here, I got the meter. Plug in the huge ground wire. Plug in the output there. It's a little hard to get to. Okay. I don't know if you could see the meter there. Yeah, so we're going to be watching right here. We're going to, as my friend Eric put it, see if we can detect any electromotive force. So there we go. We're currently at 0. I'm going to fire up the power supply. So we got 5 volts coming in. And look at this. We've got a voltage here. Now, it's a little strange that it's climbing slowly. I don't quite understand why that is. Let's just feel if any part of it is warm. I don't understand why that's climbing slowly. It may be because of this huge capacitor and this huge inductor. With a lot of these, I was experimenting with different sizes. So now it's converging at 3.5. I have to say that's an unexpected result. What I expected was this to be at about 3.3 volts. Now when you buy the fixed version of this, it'll end up at exactly 3.3 volts. This happens to be the adjustable and has a few extra resistors out there to let you set the resistance. And so what happens in practice is you never have the exact resistors to make a perfect 3.3 or whatever. So I just used the closest, and I was probably aiming for 3.5, I'm guessing, or around there. So we're at 3.48. Now if we look over at the CPU, that is made to run on about 3.3 volts, and I think it'll run fine up to 5, so we have a little bit of margin there. So I'm going to consider this a success for now, even though it's really spooky that this voltage is moving around all over the place. Let me just see. So we're not drawing any power there. Yeah, so also this regulator is unloaded. Some switchers do weird things when they're unloaded. Theoretically, I could attach the CPU. I didn't check out the pinout beforehand, so I think that's going to have to wait for the next episode. And plus, I'm pretty sure, you know, in the last episode, if you remember, I was putting in the generator voltage here, and I was seeing the same voltage come out here. The regulator was completely failing to limit the voltage down to 3.3. What that means is I was leaking out a high-ish voltage over to the CPU, so I almost definitely blew out that CPU. So I'm going to have to go and find if I have another one of those. So I'm feeling kind of good right now. This is a good result. I'm glad all we had to do is just change out a chip, and then boom, it's working. Let's see. I'm gonna try to reassemble this. Like I said, I'm not crazy about that electrical tape there, so I'll find something else and maybe glue it in place. I don't know. Gotta think about that one. In the meantime, let's put it back together. So that's kind of what this channel's about, is designing and building digital music instruments. This particular one is called the Electric Eel. I'm going to be restoring a whole bunch of stuff that I've had on shelves and haven't been using. I'm going to be showing you some new prototypes as I design them. And I guess if people have questions about how to build instruments, what platforms to use, what frequency is an A-sharp 3, should I use built-in speakers or a headphone jack or Bluetooth out on the instruments you design? All kinds of stuff like that. You want to know how A to D converters work, especially for music instruments. And that's all the kind of stuff I want to get into. And then, of course, the algorithms for the oscillators themselves. How to actually make the sounds, how to make the effects, how to do the digital signal processing, and how to really customize it so that you have your own guitar sound. Look at that, it's creeped up to 3.71. So I had a bunch of subscriptions lately in response to my last video. Thank you very much for those. I promise to continue delivering candid, fun, informative videos like this. So definitely keep liking and subscribing. And there's nowadays a notifications thing. So that's if I ever do another live spontaneous show like this, which I'm enjoying, you'll get to find out. And if you've been paying attention all these other years, I just want to thank you for having faith and coming along for the ride and seeing some of the amazing things that are going to come out of this project. All right, bye-bye for now.
Wow, 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 wow.